Okay, physics friends. This is Molly Bovis and my lovely colleague Alex Decker. We have some questions. We ran into a conundrum trying to figure out exactly how to explain the problem of we've got two blocks in an elevator, 3.2 kilograms here, 2.5 kilograms up here, and they're inside an elevator. The elevator is accelerating up at a rate of 1.3 meters per second squared. And so what we're trying to do is talk about the interaction pairs between here. And we're getting a little bit stuck. Okay, we know that if we think individually about the blocks, the question that we're asking our students is what is the force of the 2.5 kilogram block down on the 3.2 kilogram block? My initial thought, without really thinking through it too carefully, was just the fact that this block's not going to be able to push down any more than its own weight, which would be mg, 2.5 times 9.8, about 25 newtons. But we know that this 3.2 kilogram block has to be pushing up with enough force to not only balance the 2.5, but to also accelerate it at a rate of 1.3 meters per second squared. So if that's the case, then should this block be pushing down on our 3.2 block with a force of 28 newtons as opposed to 25, because we know that the force of this pushing up on it on the 2.5 has to be 28 newtons in order for this system to accelerate. So we're trying to determine, can this block push down on the 3.2 block with more force than its own weight? And where I was thinking about that was, well, we know that when if you experience the ride in an elevator, you know that when the elevator is accelerating up, you feel your body pushing harder into the floor due to inertia. And so we're wondering, does that then mean that my body actually does end up pushing harder into the floor? I actually push against the floor with a force that's greater than my own weight because of my inertia resisting this acceleration. So would I actually say that the force that I'm applying is bigger than the force of my own weight? Is that the appropriate way to explain this problem to students? So would it be appropriate to say that the 2.5 kilogram mass pushes down with a force of 28 newtons, bigger than its own weight, 3 newtons bigger than its own weight, because of this inertia, because of the fact that we're accelerating upward, and so it's going to push down harder because of the acceleration upward. Mr. Decker, did I do a good job?
Excellent.
Okay, so if you guys could help us out, we just want to make sure that we're not confusing concepts and not confusing students. Well, they're already confused. But we're just trying to make sure that we explain this appropriately and attribute forces appropriately, what's really happening in nature. So if you could give us a help out with just how to explain it, we would really, really appreciate it.